Happy Monday. Hope you all had a good weekend. Today we're going to be talking about the discriminant, which is what tells us how many solutions there are when we're solving a quadratic. But before we get started, it's been a long weekend, so I want you guys to go ahead and do the warm-up. So that's that whole entire first side. So please press pause and give these a try, and then check your work when you're done. Here's the answer to the first one. So please check your work and make any changes that you need to, and of course pause me to take as much time as you need. And here is the answer to the second. Notice the negative under the root. You can't have any negative under the root. That tells us no real answer, which makes sense when we look at the graph, because notice that there are no x-intercepts in the graph. So now go ahead and turn the page. Once again, if you needed to pause me to spend more time on that last one, that's fine. But when you're ready, turn the page, and we're going to start talking about the discriminant. So when you look at the discriminant, the stuff under the root, b squared minus 4ac, no root included, just the b squared minus 4ac in the quadratic formula. That's what tells us how many solutions there's going to be. And notice over here I added the quadratic formula so that we could refer to it. So first of all, if it's positive, in that case, we have two real solutions. So graphically, we're just going to have something that crosses the x-axis in two spots. If the discriminant value is 0, then we're going to have one real solution, which means it's basically just going to come through and just hit that x-axis in one spot. Keep in mind back here, I really probably should have put two real answers because we do have to specify that. And then lastly, if it's negative, in that case, we have no real answers, and we're going to talk about this tomorrow, but we do have two imaginary answers. And in that case, that's something like that last example you did, where it comes through and it doesn't cross the x-axis at all. So when it is positive, think about it. That does actually make sense. For example, if you had like -1 plus or minus 3 over 2, you would have two answers because you have to add the 3 and subtract the 3. However, if it were 0, if I had -1 plus or minus 0 over 2, that -1 plus 0 is the same as the -1 minus 0. And so either way there, you would only get one answer of -1/2. And then in this case, you might have -1 plus or minus the root of some negative number. And we know that we can't have that negative under the root, which is why we have the two imaginary solutions that we'll talk about tomorrow. So what I want you to do below is I want you to go ahead and I want you to try to find the discriminant and decide which category it falls into and whether or not, and how many solutions it's going to have. So you can pause me and try them. I will walk through them all as well, but I would like you to try them first. Alright, so hopefully you tried them all out. If you didn't, please pause me, try them on your own, and then check your work as we go through. So in this case, it is set equal to 0, just like we have when we solve the quadratic formula. A is 2, B is -4, and C is 3. So all we're going to do is look at the stuff under the root in the quadratic formula. So b squared minus 4ac, make sure that you put that -4 in parentheses so that your calculator remembers to square it. So -4 squared minus 4ac. When we plug that into our calculator, we get -8, which tells us there's going to be no real solutions. Alright, the next one, we're going to try this again. We want to make sure that it's set equal to 0 in order to solve the quadratic formula and also have the appropriate values for the discriminant because it has to be in standard form. A is -3, B is 5, and C is -1. So we're going to go ahead and plug it in. B squared minus 4ac. And when we plug that in, we get 13. Notice that this is a positive number as opposed to our last one where we had the negative. Since this is positive, our discriminant has a value of 13, and this has two real solutions. And then last but not least, this one's ready to go as well. A is 25, B is -40, C is 16. Plug it in, B squared minus 4ac, and this equals 0. So in that case, the value of the discriminant is 0, and so this has one real solution. Alright, so that's the big thing for the day, just being able to really explore what's underneath that root to tell you how many solutions there are. So last but not least, we're going to do some application problems. So let's go ahead and flip to the last page. And in this case, what we want to do is we want to decide if a situation is even possible, if it can occur, can it happen, will it happen, and we're going to base that off the discriminant. So we have a couple things that could happen. And so one example I have is this horse jumping over a hurdle. Notice that it has a parabolic shape. So if we look at the discriminant and we solve what's actually going on, if the discriminant is positive, we get two solutions, two real solutions. So that really tells us that it pretty much will work. If the discriminant is 0, it's going to hit the target, but it probably won't go over just because it's going to hit the top and then just kind of get stuck and fall or who knows what. So if the discriminant is 0, that gives us some information. And then if the discriminant is negative, it's definitely not going to work. We have that modeled right here. So if the discriminant is positive, you're going to see that it definitely clears the target. If it's 0, it basically gets right up to it. And if it's negative, it's basically going to hit it and not go over. So we got a little throwback here to Angry Birds. And right here we have the pig and the bird, and we know that he's going to fly. And we have some parabolic shape here. So basically what we're going to look at is halfway between the two, is that red bird going to make it over? So pause me, read these questions, and decide if it's going to happen. So pause me now. Alright, so with that 3.5-foot tree, that first one, well, clearly the bird's going to get stuck right there. So that's not going to happen. The bird is not going to make it over. If there was a 3-foot tall tree, that bird's going to get stuck right here and then not be able to make it any further. So is he going to make it? No. And then if it were only 1.5 feet tall, well, clearly he's going to be able to pass that up and make it over to the pig. So now let's go ahead and look at this in some other scenario. We have a basketball. It's shot from a 7-foot high, or 7-foot height with an upward velocity of 24 feet per second. So that's basically already taken care of in our formula here, or in our equation. So what we're going to do is we're going to use this vertical motion model in our discriminant to see if it's going to be able to reach a height of 16. Notice that's a height of 16, so we're going to go ahead and we're going to plug 16 in for our height. So 16 equals negative 16t squared plus 24t plus 7. If we're going to solve a quadratic or look at the discriminant, we need to make sure it's in standard form. So negative 16t squared plus 24t. And then we're going to go ahead and subtract our 16, so we get negative 9. A in this case is negative 16, B is 24, and C is negative 9. So we're going to go ahead and we just want to figure out if that basketball can even reach this height. So we're going to go ahead and plug it in. B squared minus 4AC. So it's 24 squared minus 4 times negative 16 times negative 9. When I plug it into my calculator, which I'm doing over here to the side, we have 24 squared. I would suggest you doing this as well, just like I do when I'm in class. And in this case, we get 0. So the basketball can reach it. But it won't go in. So now I'd like you to go ahead and read this last one, and I want you to try it out. You will check your work after you have a chance to try it on your own. Pause me, and then check your work. Okay, so below I plugged the 5.5 in for the height. I set it equal to 0. I determined my A, B, and C. And then I plugged it into the discriminant. I got a positive discriminant value. So since the only thing I want to know is whether or not that horse is going to make it, I go through and that positive discriminant allows me to answer the question. One last thing that I didn't have a chance to go over is if we go back to that previous page We did these 3 graphs and we just looked at the numerical solution, just kind of like we did on the first page. I want you guys to have an idea of what all these look like. So leave this page open in your notes because I'm going to open Desmos briefly, and I just want to show you that the first one gives us no real, the second one gives us 2 real, and the third one gives us 0 solutions. So when I do that right now, if you look over here to the left, I have my 3 graphs plugged in. I'm just going to select them one at a time. So here's our first one with that negative discriminant. And then our second one, I'll go ahead and turn this one off. And I'll turn this one on. Notice that we have our 2 real solutions. And then last but not least, I turn on the last one and notice that we just have that 1 root. So as we talk about with everything, make sure that you're checking it graphically. You have multiple ways to solve these. Feel free to go back and take your time going over this. When you are finished going over the notes, go ahead and work on your Math Excel that's due tomorrow. I hope you guys have a great afternoon, and I will see you tomorrow.